Hello student. Now we start a period of satellite. New article from Gravitation, period of satellite. So what is period? So everyone know that period means what? Period of satellite means a time taken by satellite to complete one revolution around the earth is the period of satellite. Now here, I hope everyone understood. If the question is asked what is the period of satellite, period of revolution of satellite, then time taken by satellite to complete one revolution around the earth is called as period of satellite. Now expression for period of satellite, period of revolution of satellite. Now same thing, we have to consider a satellite of mass m revolving at height h in a circular orbit with velocity vc. Let capital M mass of earth, capital R radius of earth, small r is the radius of orbit of satellite, and a diagram. So where this is earth, radius r, height h, and the speed is critical velocity. So the orbit is circular orbit. Now here period we have to find out. So we know the formula. We start with that. We know this period is given by formula 2 pi r by v. So I can write vc here. The velocity is vc for the satellite. So 2 pi r by v. But here 2 pi r as it is. This critical velocity formula we obtained in the last article and it is gm by r. So this is the critical velocity. Now I can simplify this 2 pi. This r I can write under root r square, and this root gm by r, it is divided. So I can write in multiplied format. So r by gm. So 2 pi, and this r square we can shift inside the square root, then it is r square into r. It is r cube. So r cube divided by gm, this is a period. So equation number 1. Now let me modify this equation, or I can write here small r as a r plus h also, or squaring both sides. Squaring both sides, we get t square is equal to 4, 2 square is 4, pi square is pi square, and square of this is square root get cancelled. So r cube by gm. Now I can rearrange the term and I can write 4 pi square divided by gm in a bracket and multiplied by r cube. Now this bracket is a constant. So I can write here constant into this r cube. So this is the formula of t square. So we get t square is equal to constant into this r cube. So we can write here this formula. Hence t square directly proportional to r cube. We can write, I think this is visible now, t square directly proportional to r cube, or I can write it here t square proportional to r cube. So what it means that t square proportional to r cube? T means period of revolution of satellite, r is a radius of orbit. We already learned Kepler's law. In that also we get t square proportional to r cube. The Kepler's law we learn about the planetary motion, and it is law of period. So square of revolution of period directly proportional to cube of semi-major axis. This is the Kepler's law. But here this is not for the planetary motion. This is for the satellite. We are getting t square proportional to r cube. So here we get t square proportional to r cube for satellite. So therefore we can write here conclusion also. Therefore square of period of revolution of satellite is directly proportional to the cube of this one, radius of orbit of satellite. So question may be asked in examination, show that square of period of revolution of satellite is directly proportional to cube of this radius of orbit. Then you have to write up to this. If they ask find out expression for period, then after equation number 1. So again I am writing, again equation 1 becomes, so t is equal to 2 pi under root r cube divided by gm. Now I can substitute here r as a r plus h cube divided by gm. This is the formula of period. This is expression for period. This is expression for period. In that also we can write, but gm is equal to gh into this r plus h square. By a formula of acceleration due to gravity we can write this, and if I substitute this we get t is equal to 2 pi under root r plus h cube divided by this gm is gh into r plus h bracket square. Then this r plus h bracket square and r plus h from that r plus cube get cancelled. So we get final formula 2 pi under root r plus h by gh. And this is expression for period of revolution of satellite. This is the final formula. So you have to remember derivation up to this. This is expression for period. I hope everyone understood the expression for period of satellite. Now if satellite is close to surface, now one more thing you remember here, if the satellite is close to surface, then we can write the formula of period. If h is very less as compared to r, then neglecting h, we get t is equal to 2 pi under root r by g. So this is expression for period of satellite. Now here, the value of r is fixed, g is fixed, and if you substitute these values and if you calculate the period of satellite when it is close to the surface, then I think it is coming 85 minutes, approximately 84 point something. So I don't remember the values, but you remember 85 minutes. Means when the satellite is at height 100 km from the surface, then it is revolving with a period 85 minutes. Okay, that you in 85 minutes it complete one revolution around the earth. Then only it can revolve around the earth. I hope everyone understood this. Now after that, a next article also we discuss here. Weightlessness. Weightlessness in orbiting satellite. First thing, you must have idea about when we feel the weight. We feel weight only when we exert force on floor, and at the same time floor also exert reaction force on us. Then only we feel the weight. For example, if this is surface, so this is a person exert a downward force on the floor. At the same time, floor also exert the reaction force. That reaction force is called a normal reaction. That time we feel weight. I hope everyone understood when we feel the weight. But when we are exerting force on the floor, but floor is not exerting force on us, then it is a condition of weightlessness. Now I can tell you a simple condition where on the surface of earth first, when we are in a lift, stationary lift, then if the person weighing a 50 kg in stationary lift 50 kg, if lift start moving up with some acceleration, then the weight of the person is more than 50, because acceleration of the lift we have to consider, because here the formula of the weight is here mg when it is stationary. When it is moving with acceleration a, then the formula of weight is mg plus a. When the lift is moving down, then the weight is less than 50 kg and the formula for weight is mg minus a. So these are the different formulas here. Okay. Now if I consider that you are the person in a lift, and if you cut the rope of the lift, then how much is the weight of the person in a lift? When we cut the rope, then acceleration of the lift is equal to acceleration due to gravity. Then substitute here a is equal to g. So g minus g, 0. 0 into m, 0. So here, so weight is coming 0. So freely falling body can feel a weightlessness. If anybody want to feel a weightlessness, if you jump from a certain height, you can feel weightlessness. Now here, forget about this. We have to discuss weightlessness in orbiting satellite. So if the question is asked, why astronaut feels weightlessness in orbiting satellite, you can write an explanation with the 2 points. The first point is, when we feel weight only when we exert force on the floor, at the same time floor exert force on us. And in second point you can write, in orbiting satellite both astronaut and satellite having a both having a same centripetal acceleration. They having a same centripetal acceleration. Therefore, astronaut does not exert force on the floor, as well as floor also does not exert force on astronaut. So, astronaut feels the weightlessness. I hope everyone understood this weightlessness. Now here, I think one more article from this chapter is pending, and communication satellite, that also we discuss. Communication satellite. The satellite which is used for communication is the communication satellite. And basically you remember, communication satellite having a same time period as that of Earth. Now you know that how much is the period of Earth? Earth about own axis. Earth take 24 hours to revolve about its own axis. So the communication satellite also having a same period, 24 hours. Therefore, this communication satellite is also called a geosynchronous satellite, geostationary satellite with respect to Earth. If it is a India's satellite, it is above the India. Earth rotate, then also in the same sense satellite rotate. Always we can see satellite is on the top. If we see, you know that it is at larger height, so we cannot see. But if we able to see, then we can always feel that it is at same place. So it is also called a geostationary satellite. So it is also called as parking satellite also. So uses, you know that it is used in weather forecasting, radio broadcasting, telecommunication. It is used in GPS, many more you can write. So these are the uses of communication satellite. So here we stop here. I hope everyone understood this or communication satellite.